Hey guys, what's going on? Today I'd like to show you my fix or hack or whatever you'd like to call it with these touch modules, capacitive touch modules, and the Sonoff Basic. My Sonoff Basics are already flashed with Tasmota, and I'm running them with Home Assistant. So these Sonoff Basics are the RF-R2V1s. In that case, they actually don't have the fifth GPIO 14 pin over here, so we'll be using the 3.3 RX, TX, and ground to do this. So what's the issue with the capacitive touch switches and the Sonoff? Well, they work great out of the box. You buy them on AliExpress or Amazon. They're very cheap. I think they're less than $1 a piece or so. And Dr. Z's and I believe DigiBlur as well did an awesome video on flashing the Sonoff Basics as well as hooking up these capacitive touch switches to act as your external switch. So you can cram all this inside of your light box, have a blank plate, you kind of glue this or hot glue this to the back of the blank plate, and these light up in different colors. So it's real flush and the light kind of shows through. It's real cool. This one's happened to be blue. They come blue, red, green, bunch of different colors. So the issue is when you get these all working, they work awesome right out of the box with the normal touch. You touch them, you can either have the light turn on when the relay turns on, or turn the light on when the relay is off. I prefer to do the inverted version where you have the light on the capacitive touch on when the relay's off. So like at night you could see it glowing and you could find it to touch it to turn, light or whatever you're turning on. And so that's considered inverted, I guess, and you can do that in the programming, in the Tasmota programming, so it's no big deal. It's not going to change any of your wiring or anything. So like I was saying, the capacitive touch modules work great out of the box. You touch them, the lights follow the touch, the relays turn on and off, they work great. The issue comes when when the Sonoffs are triggered with an automation, or even your display on your Home Assistant or whatever automation you're using. Say you have it set up to turn on when before the sun goes down or whatever. The light on the touch does not follow the automation, so this will stay in whatever state it was before the automation took over, sort of, or triggered the relay. So the reason it does that is because there is no the actual output as well as the LED are all sort of built onto this board, and there's no logic or anything coming from the Sonoff to say, hey, turn the LED on or off, or hey, I'm on or off. It's just everything is sending a signal out with the capacitive touch, so it has no feedback from the Sonoff. So my way of getting around that was to figure out how to isolate or separate the LED completely separate from the capacitive touch, and use the Sonoff and programming to activate it and control it. That way it would follow the automation and everything. So when you hit the button in automation, I knew the light was on or off, basically. So I figured out a pretty simple way to do it. If you can see, let's see here. This is my original kind of prototype setup here. You can see I've taken the diffuser. That's the actual LED itself. This is a capacitive touchpad, and all of this is underneath this. It's actually just transmits the light around or diffuses the light around. So the best way to do this is, you can see on top of the board here, you have VCC, you have ground, and you have out. This is the actual logic chip that is used for the actual capacitive touch. It does some magic in here, not exactly sure, so we'll just call it the magic genie inside here. When he feels a touch or you touch it, it will output a signal to this transistor right here. This transistor takes the little baby signal from the logic. It actually triggers 3.3 volts out on the front here, and if you follow the traces underneath, it goes through this resistor, which actually right here is, so 3.3 out here goes directly to the output pin, and then it goes through this resistor and through the board to the LED. So basically the LED is tied into the output here. So what we have to do is separate those two. And how we're going to do that is fairly simple. So what we need to do, flip this guy around here, is we need to actually take off this resistor as well as this resistor. So both of these are resistors. This one's actually the resistor for the LED. This is actually the pull down resistor for the output side. And I'll kind of explain that one later. So I've done probably 5 of these now. Every single time resistors have popped off, leaving the traces on the board. I haven't ripped any traces off the board or anything, so you should be good to go if you do it like this. So first thing we're going to do is take a small screwdriver, kind of like you see here. We're going to put it in between the resistor and these plastic pins here. And all you're going to do is kind of pry and flick. You can see it'll focus here. It kind of want pulled off, and you basically just flick it off. Come on, guy, focus. There we go. So you can see we've now taken that resistor off. We're going to do the same thing with this one right here. Take the screwdriver. We're going to kind of do a twisting motion with the screwdriver and pop the guy off. And there you go. So that leaves you with no resistors and open pads. So we have officially separated this output from the transistor and the pin and the LED. The LED is officially separated. Now, the tricky part is we need the 4th wire to reattach to the LED. The output pin remains the output pin, nothing of that changes. So what we need to do is add a wire to control the LED. I tried this a few different ways. I tried to take a header pin. I tried to solder it to the little pad. It worked, but the only problem with that is it just allowed leverage on the pin. When I tried to push the connector on, it ended up pulling the pad right off the circuit board here. The kind of a cool part, if something does happen, you have 2 areas here that we can both access power to the LED. So if something happens to one, we can actually solder to the other one, and you're fine. You almost got 2 chances. So I didn't go with the header pin route. Like I said, I tried it. It ended up having too much leverage on it. It actually didn't break the solder joint. It actually ripped the whole pad off of the board. So I didn't go that route. The second thing I tried, and what I'm actually going to keep, is this is my final one here, is I just took one of these, what do you call them? The jumpers. A lot of guys have these. They come in male, female. Can't remember the name of them right now. But I went ahead and used a male here. You can see when we get to it on the board, we're actually going to use females because of the rest of this. But I wanted sort of a way to disconnect this in case I took the faceplate off, because essentially I'm going to hot glue this down to the faceplate. And if you watch Dr. Z's videos or DigiBlur's videos on how to actually, how they did it, is exactly how I'm doing it, except I've figured out a way to separate the LED. It's essentially the install is the same, but so back to this. The best way that I found to do this is essentially take a wire and solder it directly to the pad. What this does is it allows some flex in the wire and stuff, and it won't rip the pad off. And you can see, if you look at the side, that I actually purposely soldered it so that it hung off the pad and 90'd up. So what's going to happen is when I hot glue this down to my my faceplate or my switch plate, my blank switch plate, I'm going to actually run a little bit extra hot glue around here and give this sort of a relief so that it doesn't break off. Once this is inside your switch housing and switch box, like I'm going to, there's not going to see a lot of movement, none at all. So you should be okay, but try to make it as robust as you can. So that's the only thing you have to do to these to separate the LED. One thing I didn't go over is exactly where we need to solder here. So you rip the two pads off. Now, like I said, you have two chances here to solder. The first one that I like to use kind of out of the way is the one all the way here on the left, this last pad. That is power to the LED, as well as the left pad on this resistor here. They both go through the board to the positive side on the LED. So you have two chances, however you want to do it. Just make sure that you do not jump solder over to the pad next to it. It was actually kind of a pain to even purposely do that, because I was messing around, I was jumping these, but so just make sure. Also make sure your wire doesn't stick off and go underneath here and touch VCC, because that's obviously not going to work either. So again, you can solder to this very last left pad here, the last side of the resistor, as well as the left side of the pad. Either or. This one was a little more out of the way, so I went ahead and went with that one. It's actually fairly easy to solder. You know, put a little bit of pre-solder on the actual pad, a little pre-solder on the actual wire, kind of put the solder gun on top of the wire, go down onto the pad, and you should be good to go. There is no way to do this without soldering. There's just no way else to access the LED. These are the only 2 points on this board that the LED comes up to. So I also did some testing. Like I said, this resistor was actually for the LED. It went from 3.3 volts to 2.7. I've been running my LED with no resistor at 3.3 volts for, I don't know, 4 days now or so, and it's not hot. It's perfectly fine. So we can eliminate the resistor anyway on that side, but we will need the resistor on the output side for the pull down. I could not get it to work without having this resistor, and it's actually this 10K ohm resistor that we popped off right here. Unfortunately, I couldn't leave that on here because it's on the other side of the LED resistor, so it kind of put it in a spot where once you get rid of, isolate the LED, you're isolating this anyway and you're kind of screwed. So there's just no way to get around it, but honestly it's not that hard. Yeah, so don't be kind of scared. It's cool, it's easy. So everything else remains exactly the same. Pop the two resistors off, solder on this last pad, have your little wire here. You can run solid wire however you want to do it. So that's the only modification you need here. The last thing is, if you probably followed Dr. Z's, most of this is probably already on here, ready to go. You can see we're using all of them. One thing to keep in mind, 3.3 volts is pretty, obvious, 3.3 volts in ground. The RX, which is also GPIO 3, that must be the output. You can't use TX. The TX can't be held low, I believe it is, on boot up, or the Sonoff won't boot. The LED, it doesn't matter, so you're good. So make sure you use RX or GPIO 3 for your output wire. That output wire will go directly to some females I didn't solder a header pin to this. I actually just took the male plastic pieces and the pins and just stuck them through and soldered them. So the last thing we need to do is put that pull down resistor back in the system. I found it the easiest way to do it is back over here. I used the one on the board that we pulled off is a 10K ohm resistor. So here's my 10K ohm resistor. It goes between ground and the output, and that basically puts it back. And I could not get it to work without it, so obviously got to put it there. Yeah, so that's all you need to do. Then your LED wire, it will solder down to the TX. So you'll use all four. Again, output must be on RX, and your resistor must go from output or RX to ground. And ground obviously is the same. The way I hook this up is take your capacitive doodad here. We got power, we have ground, and we have output. And then I have this guy, which jumps over to this guy. So these are the male ones that I just soldered down to my board. I didn't have a header pin available, so. And you're hooked up and good to go. So once you're hooked up, there's some programming and stuff that you'll have to do. I'll try to post that or show you guys. I have the generic version, generic thing you can use for the Tasmota to load. The inputs, I'm not going to be using the cases that come with because I'm going to be cramming them in my box. But do hang on to the case because it has input and output, and you need to make sure that you don't switch them, that you don't cross them or mess them up. It's the only reason I keep it. So go ahead and hook it up. I already have it hooked up, but it's off, so I'm going to go ahead and turn it on. One other really cool thing in the programming is the LED onboard no longer works. Well, it does, but it's turned off via program. And when you used to start up the Sonoff, this would flash, which basically it was like a status light, as well as the power to the LED, or to the relay. It showed you both statuses. So when it powers up, it used to blink, and what that means is it's connecting to Wi-Fi. So once it's connected and went solid or whatever, and then it turned into the LED for whenever it was on or off when you're touching it or turning the relay on and off. What's cool is if for some reason it's not connecting to Wi-Fi, that would be blinking. We programmed it so that now shows on here. So when all this is crammed inside your light switch box, all the status is out here. So if it's not connected, it'll blink. You can see, hey, what's going on. Stuff, and you'll see it when I turn it on, flip the switch on and turn it on, you'll see this blinking. So I'm gonna go ahead and do that real quick. Hopefully you guys can see this. Let's see if I can get it to sit here right. Oh, come on. All right. So you can see it's connecting to Wi-Fi just as if the onboard LED, which is really cool, and it's connected. So right now, like I said, I have it inverted. My relay's off or my light is off or whatever. So you touch it, and so my relay's on. Touch it. Good to go. And get my computer going here. It also works with the onboard button. It's really all the same. Nothing has really changed. Now here's my mouse connection. I can't move my phone, so here's my home assistant, and we're going to turn it on, and we're going to turn it off. We're going to turn it on, and we're going to turn it off. And again, you can have it reversed so that on is on, off is off. However you want to do it. And so it's pretty quick. It's awesome. Like I said, you can see. And this is connected to my Home Assistant MQTT, so it follows. Awesome. I haven't had any issues with it. I haven't crammed it in my switch box yet. I've just been finally I wanted to make a video to show you guys. There was a lot of comments on Dr. Z's video asking about it, and everybody kind of said, well, there's really no way to do it. Honestly, I think it just nobody has really tried or cared. Maybe this is a little over the top, and I just really like these little blue touch buttons. So I hope that helps people. Have any questions or anything, let me know. I hope I got everything kind of straightforward. Yeah, thank you very much.